Okay, let's continue. The next one is number 5. This has been correct by 60% of students in the first test. This is also somehow funny that if we compare, for example, this problem 6 and 5, which are shown here, I would say that this 6 is much more harder problem than this 5. But still the number 5 got a smaller percent. But probably the reason is the last x here, because this makes that mistake. Yeah. Yes, it is easier for me. I think it is easier problem. Yeah, yeah. The percentage in problem 6 was higher than in problem 5. So this means that 60% of students who made this problem in the test could make it correctly. They got right answer. But in this problem, 69%, so almost 10%. Yeah, yes, yes. I think that the reason for this, that this percentage is such slow in this problem 5, it's because this last x in this problem, because that makes most errors in this kind of problem. It is always easier when you have exponent which is simple number 5 or 3 or 3, but these make mostly errors. Yeah, yeah. So here we have this kind of expression. We have only x's there, and then we have exponents or powers there, and multiplication. So again, the order of multiplication you may choose freely. So we may multiply these numbers here, 2 times 8, so we get 16. But then we have these x's here. We have exponents or powers. There are 5, 3, 3, and this. What is the exponent of this? 1. And that you have to remember that even though it is not shown, it is 1. So we get x. The same holds as we did in. Sorry. Yeah, yeah. Yes. Yeah. Well, I will show something soon. So we have these x's here and different powers or exponents there. We count these powers together. We get 5 plus 3 plus 3 plus 1, and I will write there note exponent or power is not 0. But 1. Can you read that? Actually, we have this formula book here where we have rule for the 0 exponent here. It is one of the first formulas in this book. We have potency. This is power in Finnish language. It means this exponent format potency. And here we have the rule. If we have exponent 0, it becomes 1. We may somehow prove that. I'm not going to do very mathematical proof, but just a simple example. Well, let's count this to the end first. What do we get to the result? -12, yeah. As I said, most common error was that student had thought that this is 0, this exponent, so most common wrong answer was that there was 11 in the power or exponent there. Let's take the proof for this 0 exponent. No, this is not a good color. Is this better? One of my students bought me these pencils last year because when she saw that I had so dry pens, so she bought my new pens. Now I will take. Thank you, thank her. Yes, now it is easier to read. Exponent 0. For example, if we have this kind of number example, let's take like this 7 times 7 times 7 times 7 times 7 divided by 7 times 7 times 7 times 7. We may calculate this with 2 ways. For example, like this way 1, or how would I say? We may see that there are 4 sevens in both sides of the division line. So this means that it is 7 to the power of 4 and 7 to the power of 4. Well, actually, if we watch this division there, we have the same number in top and bottom part of this division, or in this fraction. These are same numbers, and if they are same numbers, it will come 1. But also we may think that we have exponent 4 here, and we have exponent 4 here, and we have rule in which we may subtract them from each other. We may minus these exponents. Actually, it means the same that we have here 4 sevens in the beginning. If we draw away 2 sevens at time, now we have 3, now we have 2, now we have 1, and now we have taken all away. So we have had only 0 sevens there. And here we see it is 0 sevens. And now we have an example where we have the number 7, which has the power of 0, and the same equals 1. So this number to the power to 0 equals 1. This is only a number example, but the same holds in with almost every numbers. There are one exception, and it is shown in this formula book. Actually, I have to say that this is quite theoretical with situation. I haven't ever have situation where I actually have needed that kind of calculation where this A would have been 0. So 0 to the power of 0 is nothing. It is not. It is not 0. It is nothing. It is not even 0. When if you have calculator and try to count that kind of.
Can you say that A should be a real number?
It is not nothing. It is not defined. For
it is not equal to 0, it has to be a real number.
It is undefined. Oh, sorry, you can see it. Yeah, here I have calculated. Most calculators give some kind of error sign, E or error or something like that. This gives undefined. It is not defined at all. But as I said, I haven't ever find any use for this kind of calculus. It is just a mathematical example, but there is no use with this 0 to the power 0, so it is not problem if it is not defined. Okay, 5 was that, and then we have 8, the next example. These are quite many problems in this test was that those percentages were around 60 or 70 in the test. This 8 was 69. 69%, almost 7 from 10 students could do this correctly. Oh, sorry, there's minus there. This minus. Actually, in the test there was not this multiplication marks there. It is only this kind of expression, but it means multiplication. It is not shown. What would you do in this? Yeah. There are here is multiplication, and again the order is not important. So it is possible to first multiply these first brackets or m and plus inside the brackets with 3. It is possible 3 times 4. 3 times m and 3 times 4. But it is also possible to multiply first these two brackets together. It is a case of opinion. I don't know which is a better. Maybe I would do so that I would first count this multiplication. At least when there is big number in front of it. Because if there is, for example, 257, this number, and you have to multiply this, then you get big numbers here, and then you have count with big numbers, so it is easier to first multiply these with each other, and then after that multiply with this factor. So I will do it so that these will be multiplied m's together, and then m and minus 2. So this will be multiplied with each of these, and then this 4 will be multiplied with each of these. So there will be 4 multiplications when we do that. 3 times, and then let's have a big parentheses or brackets there. First, m times m, what becomes? M squared, yeah, and then m times minus 2. M minus 2m, and then that now we have multiplied with this m here. let's go to the 4. What comes? 4m plus 4m. And yeah. I thought that it would be bigger expression there, so I'm sorry to get so wide brackets. And can we do something with this expression? Simplify it. Yeah. M squared and it, yeah. Yeah. And after this we do it again that we will multiply these all with 3. 3m squared plus 6m, yeah, minus 24. Yeah. And this is the final result. By the way, there is sometimes these kind of multiplications are nasty ones, and especially when you make some mistake and you want to check you get wrong answer and you try to find where the error comes. So many times this is not so easy to read, even though I have myself written, and especially if someone else has calculated that problem. Then I would suggest you to use some kind of table method. So, for example, in this problem, this m plus n multiplied with m minus 2, you may write it like this: m plus 4. Let's take a table here. Here we have m plus 4, and then m minus 2 you may write like this. So you get some kind of multiplication table here. And with the help of this table, it is easier to remember to do every multiplications. In this method, you have to be careful that you remember to do everything and not do something twice. Only once, but you need to do everything at least at once time. So you have 4 multiplications here. But in this table format, you see that you have to get 4 multiplication there, and the order is not important. You may calculate in what order you like. For example, if you want to start with the easiest one, you see that there are, this is multiplication table. I will do multiplications here. So, for example, you want to start with the most easy one. We have plus 4 times minus 2. 4 times 2 equals 8, and plus and minus, it means minus 8. So we get this minus 8 here first. We see it here in the end of the this bracket expression. And then, for example, this is easy. Plus 4 times m, it is that is plus 4m, and it is the same as here. Here you see plus 4m. And then we have here m times minus 2, that becomes 2m. It is here. And here we have m times m, that is m squared. So with this method you actually get everything, and if you make some kind of mistake and you can't find the error, it is much easier to try to find error from this table, because now you know that where did you get this plus 4m. You get it with this and this. And if you, for example, have here 8m, so it is easy to find out that the error came from in this stage or this step. This table method is most useful if you have here we have binomes, we have two numbers or two letters in this expression. But for example, if you have 4 there, for example, m to the power of 3 or plus m squared plus 5m plus 4 times same kind of expression. If you have four parts of that expression and it is multiplied with another one, so it becomes 16 multiplications. And with the help of table, you just make a table which have 4 rows and 4 columns, and you find those 16 numbers or 16 letters there quite easily, and you may calculate in what order you like.
So it is like basically plus I need to figure down yes. If you have this x plus 4 in the bracket,
X
x plus 4 in the
Yeah.
bracket times x plus minus 1 times x plus minus 5.
Yes, yes, that is. Then you should have try a three-dimensional table. Yeah, it is not possible to do easily, but two brackets you may count with this. What is, yeah, that is a good question. Yeah. Yes, number 8 was that, and what is the next one? It is an equation 20 there. Solve variable x, ratkaise muuttuja x yhtälöstä in Finnish. Ratkaise muuttuja, solve variable. Let's take that. Do I have paper? Yes. Actually, in this problem, we are almost in an almost same situation as we had in this first problem today, if I remember correct, 18. It is almost the same kind of equation, and this cross multiplication is quite an easy way to solve this. This was made correctly by 74%. Again, I'm a bit confused that this 18 was in the first step, in the first test. It seems to be a little harder for students than in this numbers 20, even though, in my opinion, this looks like a little bit easier one, because there are, well, this is my opinion, but actually when we solve this problem, it is solved with the same way, but
I think if I will guess
yeah,
the difference, the reason why the difference, the rules.
Yeah.
If you do this one time ago, so
Yeah.
more rules.
Yeah. Yeah. where we will use this cross multiplication here. Of course, in this problem, it would have been possible also do the same as we did, or almost the same as we did in this problem 4. We get the same number in the bottom part of these fractions. Here we could do the same. We have 3 and 7. If we multiply this fraction top and bottom parts with 7, we would get 21 in the bottom part. And here if we multiply with 3, we get here also 21. And if we get same numbers in the bottom part, then we can continue with the top part and forget the numbers in the bottom part of those fractions. But that is a possibility with this problem. But of course, it is possible also with this problem, but it doesn't get many. So it is not, in my opinion, so easy way to solve all. So I would say that we would do this cross multiplication. And again, it is not necessary to do it in some specific order. For example, you may multiply these first and then after that these. I think I usually do like that. So we get 3 times x minus 1 equals 4 times. And as I have said, that many problems here use some knowledge with earlier problems. So for example, this is 18. We have the exactly same situation here in the second step. So it is only repeating the next few steps. Let's multiply. And tell me what shall I write here. This is easy to learn to solve, but if I mention in this situation also quite common mistake, it is only because of not being careful enough. Many times in this kind of equation solving, everything goes well, but in this last part, I think I've seen during my career a lot of sixes here. So many times you are not careful enough, yeah, and you forget that you are multiplying, not adding. And for example, if you get an error, check that you don't have 6 here, 4 plus 6, but it should be multiplication. And then we again. Actually, we could do so that we move x's to the right hand side and numbers to the left hand side, but I will use the most common way to have x's to the left hand side. Right now, in this problem, we have this is actually not a good way, because we will get the minus sign to the left hand side, but let's not care about that. And this minus 3 will be moved to right hand side. So what will we get?
X minus 12x. 3 minus 8. Minus 8 plus 3.
Yeah, the same. Yeah, order is not necessary, but if I put this minus 8 first, so minus 8 plus 3 or 3 minus 8, the same thing. as I said, that in this situation we get here negative number in front of x minus 9 x, and here we get minus 5. This is not a good thing, but it is not a big problem. Usually it is easier and more nice to have a positive number in front of x, but right now we don't have. But then we do the same. We want to find out what value x will get. We have to divide with minus 9. So we divide divide with minus 9, so we get x equals minus 5 divided by minus 9. Now we get both are negative numbers. Actually, we may think this is not a nice mathematics, but we may think this like cancelling these minuses away.
It's actually multiplying by minus 1.
Yeah, it is actually same as multiplying with minus
Both
1.
sides.
Yeah, both sides. Yeah, but technically it is the same as we somehow cancel these minuses away, so we get 5 divided by 9. But it is the same as was said. If we multiply both of these with minus 1, then we get plus 5 and plus 9, so the sign changes. 5
Yeah, that
divided
would
by
be more clear if we do it on a step process, like when you have minus 9x equal to minus 5, we multiply both sides by minus 1, so it's a little more simpler to understand.
Yes. As was said, in this step we could multiply this with minus 1, and after that we get, this is not a good color. After that, when we multiply with minus 1, the sign changes, so it comes 9, 8 equals 5.
I think you wrote divide on the minus 1. Not multiply by divide.
Yeah, the same. Yeah,
yes,
yeah. But thank you. Yes, of course. I watched this here, and I wrote the division mark there. But it is the same, and it is easier to think about multiplication with minus 1 than dividing by minus 1. Yeah, thank you. Actually, etc. It continues like here. We get now positive numbers, but actually we could do also so that when we have this kind of equation here and we see that we have minus signs in both sides, we could move those to the other side of equation. So if we move these to the other side, the sign changes, so we get 5 equals 9x, and it is the same as here but in the different direction. So we could do that also. Or then we could do in this stage, when we move to 12x to the left hand side and minus 3 to the right hand side, we would do so that we would move 3x to the right hand side and minus 8 to the left hand side. And after that we could get positive numbers to both sides. But many times it is more quick to solve the problem with some kind of mechanical way and always do the same with the same way. So I think this is good way to do it. So try to move all x's to the left hand side, and then after in the end of that solution you just have to divide these minus signs away. So you get the right answer, though even though there may be some extra steps there. Yeah. That was 20. I will do so that I will leave the next problem for you to solve. It is number 10. This was made correctly by 71% in the first test. And the problem is simplify this expression. I would like to see how you are solving this problem, because I think there might be many ways to do that.
Yeah. The first way is to use the formula, but the easier way, if you don't know the formula, you just make two brackets and multiply them.
Yeah, okay. Let's see how you do that. What? Yes, I'd like you to do that. So you all, not only you, you do with the box or do with the formula. Yeah, yeah. And you don't want to do it yourself. Let's continue to the end of the lesson, so you don't have to do yourself. Way 1. We will do it like this. If we use this table format, actually this power or exponent 2, that means that there is a multiplication where we have this bracket 2 times. It is multiplied with each other or with itself. And with the table way, we could write this x minus 3, 1 times x minus 3, 1, 3y, x minus y in Finnish, x minus 3y in Finnish, 3. And here I will write the table here. And let's fill the table together. What will we get here? X squared, and here, yeah, minus 3xy. The order is not important, but maybe it's a good habit to use alphabetical order, so x before y. And here, yeah, and the last one. Yeah, is it correct? No, plus. Yeah. Minus 2. There are two minuses or even number of minus signs, so it will become a plus. And then we have here, x squared and 9 y squared, and then we have this xy parts here, so there are minus 3 and minus 3, so minus 6. So the final answer is x squared minus 6y plus. Yeah. But as it was told that there are also a formula for this. If you don't remember it, it is shown in, I think, every mathematical formula books. In the first pages here we have minus sign here, so there is something minus something else, and to the squared, and we have a formula here. Here we have a minus b squared, and this is a formula for that.
That could be not the same. Could be not the same. Could work a lot.
And now we have this kind of problem, and we just see that there are minus sign there, and there are exponent or power of 2, and we see that the first here is x, and that means same as a in this formula. And here we have minus sign, and after that there is 3y, so this here is the same as b. So a is this part in front of minus sign, and b is the part after the minus sign. So this minus sign does not belong to b. B is only this 3y.
Mostly people mistake that b is like minus b,
Yeah,
they
yeah.
calculate as minus. So
yeah, that is very usual mistake is that the thing that usually this minus, it is the sign for this 3y, but in this formula this b means the number or the letter after this minus sign. So now we, with the help of this formula, we just put the x and 3y in the correct place. We have a squared, so x should be squared. This is the same as a squared. Then we have in this formula we have minus 2 times a times b, minus 2 times a. A is the same as x, and b is the same as 3y. And so this is the same as 2 times a times b. And then we have this last one, b squared, so we have 3y squared. Here we have to remember to put these brackets here, because without brackets, I think most common error is that we have only 3 times y squared if we don't write these brackets, but it should be 9, and that's because this 3 should also get the power of 2. So here we have the final result. 3 squared equals 9, and y squared equals 9. y squared. So this was b squared here. I will write here note. Okay, I think our lesson today is over. So thank you for today. And do we have tomorrow? Or?
Yeah, tomorrow.
Yeah, okay.
On Friday.
Let's see.
On Friday. We have on Friday, not tomorrow.
Ah, okay. Yeah, okay.
Tomorrow online. Yeah. Kiitos.
Kiitos.